Today,
Yes.
before beginning with our chemistry session, or any other topics in 12th standard, what you have in chemistry, uh, I always prefer to go with the basics because whenever we are discussing uh, a same basic fundamental point should not be repeated again and again. What does it mean? What do you mean by mole? What do you mean by this? So when we have fundamental points very clear in our in chemistry subjects, then for us the language of chemistry will always help us.
Okay.
So in every sessions, first one or two class I always go through basic concepts, what we have studied maybe in 11th as well to some extent.
Okay.
So I prefer to take that one first. The reason is that it will build a strong base for you, so that whenever we are having a discussion on subjects like thermodynamics, electrochemistry, numericals, these concepts really helps a lot. Many problems you will solve like on a click if you understand the fundamental points. And in CBSE, MCQs specifically, they are not direct MCQs like question and that's answer. It's never like that. If you just open last few years paper, you'll always see that they are mostly based on the conceptual understanding of the student. Few questions you may find a direct answer like for F block and D block elements, what transition color they show, but in general, they are asking a tricky questions so that you won't get marks so easily in that kind of subjects and that kind of sections. So today I will prefer to go with this some basic concepts of chemistry, which are not some basics are very important and fundamental points. So just to begin with, uh, we'll go with the law of one second. This is yeah. So to begin with, I'll start with law of conservation of mass. We all know that mass cannot be created from it can be converted in one form to another form. But how do we use it in chemistry? You must be solving till now. I assume that you have come into 12th standard, so you would have in 11th standard you have done lots of organic chemical reactions, reactants giving product. So there is a law of conservation of mass is there, always used in a stoichiometric way. I mean to say that let's take an example. So yeah. So let's take a formation of carbon dioxide. You see here, what elements are required for to form this carbon dioxide? It's very basic, it's a very fundamental carbon and oxygen.
Correct.
Carbon plus oxygen give you carbon dioxide. The chemical reaction would be carbon plus oxygen gives you carbon dioxide. It's a very common. In a specific case, we are not getting into technicality that carbon monoxide is also formed in between as a intermediate state, but just to make you understand right now, a concept of law of conservation of mass. So what is an atomic weight for carbon? It's 12. And for oxygen, we'll take how much? Many of us will write 16, but it's not. Whenever we are seeing the here, oxygen is in the form of a molecule.
Diatomic.
It's not in an atomic.
Uh,
It's a diatomic.
diatomic.
So it always be a
16.
not 16. It's a 32.
Correct.
So that's how we see that we are adding 32. Yes. So in left hand side, you will see that 12 plus 32 forms how much? Here you'll see how much
44.
it becomes 44 for carbon and oxygen. Here it is 44 again. Sorry, 1 second. So again, so you will see here that total mass of reactant is 44. Total mass of product is 44. So mass of reactant becomes mass of product. That's how the mass of this. That's how the law of conservation of mass is written, is understood. See, this is a very, very basic example.
Hmm.
This is always helpful for us when we are doing a very complicated chemical reactions where we have to do stoichiometrically balancing of a chemical equation. If you write any chemical reaction without stoichiometrically balancing of it, then you're doing a big mess with your basic understanding of law of conservation of mass, because you are breaking that rule. And if you break that rule, then you will fall into prey to wrong mistakes, like taking wrong calculation for the mass. Then your all mathematical calculation for any reaction in terms of enthalpy and all, which you are going to study in coming chapters and all, will be a big mess. So this, whenever we are doing this chemical reaction, we have to always see to balance a chemical reaction. This is why is it so important, because it's a basic fundamental principle to follow law of conservation of mass.
Understood.
Energy can neither be created nor be destroyed. Let's get into some other next concept, law of definite proportions or definite compositions. Let's say, let us consider a molecule, water molecule. So see, water molecule is a water molecule from wherever it comes. This is what this law says. It's not that gold of Dubai is different and gold of India is different. This is what, in simple terms and a little simple language, what I'm trying to tell you. This is what this law says to us. So from lake, water comes, from ocean comes, from any laboratory, like any cell reaction, we know H2O2 fuel. So here O2 means oxygen. See, whenever we are writing oxygen, we can't write O only. We have to write O2, because we have to write in their stable state form. That's a very basic understanding of it. So by weight, it is this much. It is always be by weight. Hydrogen will be 11.11% and oxygen will be 8.89% by weight. From wherever it may comes, irrespective of the source. That's a second and very important law of understanding of definite proportions. Law of multiple proportions. This is very confusing for many kids, and it's a very important point, because this usually comes in MCQs, at least in your school, in your college, when you're going to give any exam. They always trick you with this particular law. Let's see how it is. So as we discussed in our first chemical reaction, that कार्बन डाइऑक्साइड जो बनता है, कभी कभी हम लोग बोलते हैं ना, in between carbon monoxide भी form होता है, it's intermediate state. So here let's say law of multiple proportions. So carbon plus oxygen gives you carbon dioxide, and it may give you carbon monoxide as well. So on analysis, it was found that if 1 kg of carbon was taken, it reacts with 2.66 gram of oxygen to form carbon dioxide. So on analysis, basically it's a higher like gas spectrography. They all use it in the big labs, in chemical labs. That's how they analyze in what proportion they are these molecules are reacting. So these are like analytical part. But this was the founding. Let's see. For carbon monoxide, it reacts only with 1.33 grams of oxygen. When we take the simple ratio, when we take the ratio of these two components, it is always a whole ratio, 2:1. It is always a whole ratio. This is a very important point of this whole law actually. This will never be in the fraction. If two elements combine with each other, forming two or more compounds with different compositions by weight. But the if we take the masses and we form we take a ratio of it, it will always be a whole number. It cannot be in fraction. It cannot be in fraction. This is a very important point. So they will trick you always in this kind of questions. I will not do this first of all numericals. This is a revision of our what we have studied till now, so that when we start with our main subjects in chemistry, so you'll be familiar with these terminologies. So atomic mass. Definitely, it's a very basic, and we have studied in our ninth and 10th as well. Can we see atom? Definitely, we can't. Even scientists till now have not able to see the atom. To be very frank and open to you, whatever we are seeing, it is just a imaginary concept because um, they are all theologically presenting, but it's not a proven fact how the atom looks. But this is like some trial and error method. Till now, they have found that this is somehow it looks. Maybe it will be looking like that. In some in coming years, maybe they will completely change whole theory. But till now, this is a most acceptable theory for all the scientists. So, can we weigh an atom? It's not possible. So, how do we calculate a mass of an atom? It's a mass spectrography. This is a very commonly used in any standard good PhD labs. You will see this uh, instrument called mass spectrometer. Here they break the compound and they analyze on the basis of relatively how how much it may weight. So in this way, they have calculated the weight of chlorine, and it was found 35.5 AMU. It's atomic mass unit. It's a unit. It's a name given to unit. It's not that AMU may be a gram or maybe like that. It's not at all like that. And last, since maybe back 2 3 years back, AMU was replaced by term U on this, the new name given for that. It's unified units. The reason is that it confuses with some more terminologies has come into physics as well. So that's the reason. So who contributes to the mass of an chlorine? So we all know that electrons has negligible mass. So none of us will consider the weight of electrons because it comes in the power of 10 raised to minus 33, 31, 33 like that. So, but protons and neutrons, they do. So for chlorine, we see 17 proton and 18 neutron. You may say, sir, it is 35. Then why you are saying 35.5? So here comes a concept called isotopes. You would have heard a lot of it. Isotopes and isobars. This is a very, very common question asked for what you say, tell the differences between isotopes and isobars. Very common questions. So we'll address it in coming lectures. So here the concept of isotopes comes. So what are isotopes? They have same atomic number but different mass number. It's like coming from same family but have different weight. So we take an average weight of a family member like that. That's how you sit on. But they all are chlorine only. It's not that एक chlorine है तो दूसरा chlorine नहीं है, ऐसा नहीं है. They are relative. That's why they are. You can take it as a relative as synonyms for isotope.
Because
From
as long
same
as they have
family.
the same atomic number, then we say the element is same.
Exactly.
Yeah.
किसी भी एलिमेंट को वो नाम देने के लिए the most important part is their atomic number, not the mass number. You would have read in your Mendeleev's model, and then Moseley's model, and Dalton theories. At last, when we have modern periodic table, you would have noticed that the most basic important concept they have taken into picture is it is all based on the atomic number gradually increasing. That's how they kept some space empty. Maybe they will be found in future, and we are seeing that they have found actually some names you will see in F block and D block elements in the name of scientists because they have found it in their honor. To honor them, we have kept the element's name in their name. Actually, it should be kept in the name of Lord, but unfortunately, they were the medium. So jokes apart. So that's how. So for chlorine, this is a very standard example. for chlorine. We have isotopes for oxygen. We have isotopes for carbon. There are isotopes for many elements. So this is isotopes for chlorine with different mass number. You see, below is the atomic number and above is the mass number. Am I right?
Correct.
Chlorine is 17.
Correct.
Last electron is empty. You would have SPD. You would have Uphouse principle. You would have done in 11th standard. If you have not done, we'll do it again. When if you feel doubt in that, you can just tell me. I can teach you. It's a very simple concept. You don't have to mugify that. I have seen many kids do the same mistake. 1, 2, 3, 4, 5, 1, 2, 1, 2, 1, 2, like this. They will draw the arrow because it is given in the textbook. This is just to explain you, but you don't have to mug. You have to understand what are the orbitals and how they are arranged. Then automatically will write the electronic configuration. And definitely this is a very it comes in paper to write the electronic configuration for a particular element, or they will ask you something like that in a tricky way, where the last electron enters like that maybe. So just to not to move from the topic. So here is chlorine. You see that chlorine? So here we see that one chlorine is with 35, one chlorine is with 36, one chlorine is with 37. So we all know that how we calculate the average. We know, we studied in our schools. So they have same atomic number, but they have different mass number. So they are isotopes. So how to choose which mass to be taken? So we take an average. In what amount all are present. This is in 37%. This is in 4%. This is with 21%.
Yeah.
This is always taken. Sir, don't ask कि पूरी दुनिया का क्लोरीन जमा करके चेक करते, ऐसा कुछ नहीं होता है. This is always, they always take a set and they extrapolate it. Chemistry is more of imagining. So don't get into shock कि सर पूरा दुनिया का वजन किया, ऐसा कुछ नहीं होता. ठीक है? So that's how they calculate it. Basically 0.75 into 35, then 0.4 into 36. They have calculated average of atomics. And what they found out? This is the formula. So for 35 into 75 plus 36.
So each of the percent occurrence acts like their weight. So it is like a weighted average.
Yes, this is the weight percentage we are taking.
Correct.
And instead of taking 100 for individual, we have make it 100 for common, because it's a common denominator. So it's a mathematic principle that you can make it a common for all. So that's how you got 35.46. Just to make it easy for us to calculate, it's 35.5 unit. Still, it's a average one, but it is an acceptable one, because even our instruments also, when we are using and all, it is not so accurate that you will always get 35.5. It is always an average, just to make us understand, okay, this is chlorine element. That's how they all understand and study. Relative mass unit, atomic mass, basically. So this is, we divide. This is a very common example we have studied from our textbook as well. You would have gone through this example in your textbook. So I'm just repeating it again. So we have a watermelon and have divided into 12 pieces. So does one piece becomes a watermelon? It's never equal. It's a relative mass. Then how do we calculate it? It is 1/12. One piece is 1/12 of that one big watermelon. It's a comparative. Relative means always in relation. Whenever in whole science subject, whenever you hear this word relative, it is always in reference to some other, or in comparison with some other things.
Let's with some standard thing.
Exactly. If you go into physics also, there's a relative reference.
Yeah.
Frame of reference. We see for velocity, you see always relativity. theory of I don't want to get into physics right now, but here this mass is in a relative atomic mass.
Relative, yeah.
So see, what we do, if अगर हमें एक का weight पता है ना, तो we relate with others. This is how you calculate the weight of other atomic elements in chemistry. ऐसा नहीं कि हर एक एलिमेंट का आप मास स्पेक्ट्रोस्कोपी लोगे, करोगे, उसका कंपाउंड बनाओगे. It is not possible. Even though, because some are highly reactive, some can be done. They did with some elements, but for all elements they can't do. That's how they did a relative way to compare it.
Okay.
This is very very helpful for us, so that we can compare and understand. Oh, जैसे मैं आपको बोलूं कि मेरा वेट 88 kg है, तो मे बी आप सोचोगे ओके, बट मैं बोलूं मेरा 88 kg लगभग एक बाइक के जितना मेरा वेट है. तो यू कैन अंडरस्टैंड. हाँ, आपको बाइक का वेट आपको आइडिया है, तो आपको मेरा वेट का भी आइडिया आ जाएगा. लाइक दिस, like same way we take an example in chemistry, we compare the weights of atom. It's a theory of relativity, or theory, sorry, relative atomic mass.
Relative atomic mass.
Yes. So why 12? Because it was broken in 12 pieces.
12
That's
pieces.
why it's 12. Right?
Correct.
So it was a 12th piece. I mean, one of the piece was 12.
Correct.
So let's see how why we are taking carbon. I'll get into this in a later stage. But let's go with the example of carbon. See, if you understand this concept now, then for you in coming time, the chapter of solutions will these concepts are very very helpful in the chapter called solutions, first chapter of your chemistry. This will solve your maximum problems. First, you have to understand, because when I'll discuss with you equivalent weight, equivalent mass. Then, sir, आप वो क्या था वो मुझे याद नहीं आ रहा. So this will help you in that. We'll get into it. This is very important point. That's why it is included in your first, when you are introduced with chemistry. This chapter was introduced to you. So it's a 12. So we all know that we are not considering the weight of electrons. So proton is 6 and neutrons are 6. Okay, total gets down to 12. This is the following relation. So one mass of particle will become to the mass of carbon atom. क्या ऐसा आपको लगता है? अभी मैंने एक एग्जांपल दिखाया था इसके पहले वाला वाटरमेलन का. एक पीस क्या अपना एक पूरा वाटरमेलन हो गया था?
No, it doesn't become, because it divided watermelon into 12 parts. So one piece was 1/12 of the actual watermelon.
Exactly. Here we go the same way, because it will become 1/12 part of carbon atom.
Correct.
If you understood this, this is how we get the weights of other atom relatively. Why carbon atom? You may ask this question, because this is the most stable one. You'll find the whole chemistry based on it, organic chemistry. And you would have understood this very important question comes into CBSE. Why carbon is showing itself the different chemistry, or why carbon is more stable? Because of one property called, do you remember? What is that property of carbon which makes more special than any other element in whole periodic table?
So
Catenation.
I'm just guessing. Maybe I'm wrong. It is it has like how much, four electrons in the last orbit. So it is because of that.
Silicon also has 4 electrons, same element, same group, same almost similar stability. The electronegativity and catenation property, because silicon has different electron. Because ये ऐसा है कि it has many things favorable for the catenation property, like forming bonds, multiple bonds. In all, like silicon also forms 4 it can also form 4 electron, but the structure is little bigger.
Hmm. It has
So it
more
that's
orbitals.
yes, exactly. And so, but carbon is small, fits everywhere with almost every element. It can form bonds. That's how most of the people play with carbon. You never heard that oxygen dating or silicon dating.
Hmm.
Why only carbon dating?
Hmm.
Because it is more stable. So biologically speaking, you can go back to the calculation of this
The age,
ages
age
and
of
all,
any
because of its stability factor and all. There are
article.
some more. There are many more factors. This I'm just sharing one of it.
Okay.
Why carbon is important. So one second. Atomic mass. So most of us, now I guess by now you must be knowing about this atomic mass. What is atomic mass? Because till now I have discussed with you with atomic number. तो उसमें मैंने atomic mass के बारे में बहुत discuss किया आपसे. Can you tell me what you have understood?
I think mass is number of neutrons plus number of protons will give the atomic mass, correct?
Yes, but in calculation we take an average relative mass of
Average
element.
according to the
Yes, yes,
isotopes and the abundance it is present. Yeah.
exactly, exactly. But now we'll take in terms of carbon.
Hmm.
So we'll see how. Why carbon only? As I told you before, it's the most stable one. So see, मेरा weight अगर lifetime, अगर आपका weight आज क्या है? Let's say you are 60. एक साल पहले बिकॉज आपके पास स्कूल से बहुत छुट्टी थी आपको, तब मस्त मजे ले रहे थे घर पे, तो आपका वेट 70 हो गया था. नहीं, अब 12th आ गया, प्रेशर में मे बी 50 हो जाए. नहीं, so your weight is not so constant right now. But after certain age, you see that maybe you can check your father or grandfather, they hardly change their weight 1 or 2 kg, except they are sick and all, because now they are reached to the age that they can't eat more and they can't eat less also. Same way, the carbon is also showing similar kind of stability. That's why we are taking carbon to pictures. वो stable है इसलिए हम लोग उसको consider कर रहे हैं. ठीक है? It's not in your syllabus, but in highest classes and all, people really take other atoms also for catching on the masses for other elements other than carbon also. But it is just for the PhD theories. It's not useful at all. Carbon does the job enough. Carbon से काम हो जाता है हमारा. It's a gram atomic mass. It's a just given the name gram. It's not that actually it's a gram. It's not 1 gram का एक carbon. It is just given so that we can. I had some questions with this, but I'm not taking it. The reason is that, oh, that's the end of session for one slides. So, so I will request you, if you have questions till now, you can ask, or I'll ask the questions to you so that it will clarify the subjects to me.